This is just a quick little demonstration of how to go about graphing a polar graph. They're not really super easy, but with this program it makes it look a little bit understandable. So what we're doing here is we're going to be plotting coordinates, so r theta according to this equation up here. So we have r equals 4 sine of 5 theta. We're going to plug in different angles for theta, starting off with 0, 30, 45, 60, 90, and then rotating all the way around. So I'm going to have the computer do this for us. It makes it a lot quicker. So my first angle is 0, so we get the coordinate 0, 0. The green line off to the left here, or to the right here, this is going to represent our angle direction. The r is going to represent our radius, and the measure of the angle will be shown up here when we start opening it up. So let's open it up a little bit. And the blue part is going to be the graph itself. The black point is the exact point, 2.42, 7.45 degrees. So we're barely off the ground here, and we're already 2.42 away from the origin. All right, let's keep rotating. So it goes further out and reaches a maximum right about there. So at about 18.33 degrees, probably about 18 degrees or so. And the maximum distance is 4 away. Then it starts coming back in as the radius rotates. Now as it comes back in, it finishes off this nice leaf, and you can see here that the radius r and theta gives you, that point. And when we complete the leaf, something interesting happens. After this point, the sine of 5 theta actually becomes negative, and your radius actually goes the opposite direction. So here my angle is pointing in this direction, but my radius is going in its opposite direction. Therefore, the radius is negative. Even though the angle is a small angle, this is still someplace in the third quadrant. So that's going to draw another portion of the graph. And then we come back towards the origin. So far the angle has reached, let's see, back to the origin, at about 72 degrees. And then it flips back up to the top. The angle keeps big and bigger, and the radius keeps changing size according to that angle. And then we're going a negative radius again, negative 1.83 and so forth. So this completes drawing this picture in 180 degrees. After that, it starts repeating itself. And this is a rare one that does repeat itself, which is kind of cool. But that's all there is to polar graphing. So for every angle theta that's created here, we plug it into the equation and generate an r. So a table would come in really handy of different angle thetas plugged into 4 sine of 5 theta and generating this new radius every time you plug in an angle, and then you go and plot on this nice polar graph. So, pretty cool.